So welcome everyone. My name is Tosin, as was mentioned, and I'll be presenting Småprat, DialoGPT for natural language generation of Swedish dialogue by transfer learning. My co-authors are listed on the slide that you can see. We have Richard from Rice and then other co-authors from Luleå University of Technology. This is a look at the outline. In the course of the outline, at some part, we will briefly switch over to the Hugging Face platform to look at a demo of the hosted model, particularly the English, where we will see example. The objective of this work for us was to empirically investigate the possibilities of transfer learning from an English pre-trained model to Swedish downstream task. This is especially without using any multilingual model, which is usually the norm. For example, you have MBERT, you also have MT5, which are pre-trained models on several languages, sometimes over 100 languages. But we wanted to test a monolingual pre-trained model to see how it can adapt to a foreign target language. And then we also evaluated across various data sets of different sizes in Swedish. And then finally, we did human evaluation to see the human likeness of the generated responses of the various models. Now, the methodology, of course, was to conduct experiments using the DialoGPT medium model from the original paper. The medium model was seen to perform best among the models that were trained. Of course, it had 24 transformer layers and then over 300 million parameters. And then we compared with a sec-to-sec LSTM baseline, which had attention mechanism. We used a context size of 7, and then we did a data split of 80 to 10 to 10 for the training set, the dev set, and the test set. Like was said earlier, we did automatic and human evaluation. The human evaluation was based on 30 single-turn conversations. And then for the data sets that we used, we tried 2 sizes of Reddit dataset. I should mention at this point that the DialoGPT itself was pre-trained on English Reddit of over 100, I think over 130 million multiple turns of conversation. So in our case, we're fine-tuning on a very tiny fraction of such amount of data set. And then we use 3 sizes of the Familiar Leave. The Familiar Leave is a blog that actually hosts different conversations. It's Swedish for family life, where they talk about different subjects about family life. And of course, Reddit talks about, it's a blog also that hosts different kinds of conversation on all kinds of topics. And then we had the GDC, that's the Gothenburg Dialogue Corpus. We see their turns there. And then we also compared with the multi-woes English dataset, which is a dataset comprising of multiple domains, whether it's conversations about restaurants, the train station, about getting a taxi, about going to the airport. So it had conversations across several domains. Now, in our work, we had to use, of course, a decoding scheme. And then decoding schemes, there are several of them. We focused on using top case sampling and top piece sampling. And here you see an example of top piece sampling because it has advantage over the other types of decoding algorithms that we may consider. The top piece sampling is quite similar to top case sampling, but it uses an hyperparameter which we call P, which is the minimum probability we want the subset of vocabulary that we want to consider to have, from where we will now pick the next token that will be generated. So you will see in the first time step here, even though the P is specified as 0.93, we could have quite a number of possibilities within the subset of vocabularies. And by the next time step, the only 3 tokens could give us a minimum of that same hyperparameter probability, which is 0.93. So top P sampling has been shown to be more robust compared to the other types of decoding scheme. Also, here we have details about the model generation, how we actually fixed values for the various variables. For example, the maximum length of sequence we will generate, we pegged it at 200 because it becomes more difficult for the model if it has to generate far lengthier sentences or conversation. Then, of course, we set the no repeat n-gram size to 3. We don't want to be too restrictive. For example, if we're having a conversation that has to do with New York, New York has 2 words that are tied together. And then there may be instances where we will need to speak about New York twice in a conversation. So we want a value that is higher than just 2 words. So we set it at 3. Then you would see do sample set to true, top K set to 100, top P 0.7 in this case, and then temperature, which adds a bit of diversity to the distribution. Now, we had mentioned earlier that we looked at automatic metric and then human evaluation. We use perplexity in this work for automatic metric. Usually the lower the perplexity, it implies higher probability of text, which is a good thing, but lower perplexity does not guarantee diversity. So this is a challenge with automatic metrics. They are not perfect. That's why it's always good to still do human evaluation at the end of the day. So we went further to do human evaluation, where we had a Likert scale and had four values: clearly human-like, somewhat human-like, not very human-like, and clearly not human. So you would see the results for the various data sets that were trained, where we had the best perplexity score for the Swedish with the familiar leave of over 1 million turns of conversation, where the depth set had just 7.15, and then the test set about 1.5 as well. Of course, compared with the English multi-words, which had a lower perplexity than what we would get from the Swedish. I think this is not so surprising, given that the original pre-trained model itself is in English. So it's not so surprising. And then you would see the human likeness results. The best was, of course, the one that had the largest data set for fine-tuning, the familiar leave over 1 million, which had almost 0.6 in terms of the mean, and then followed by the GDC, and then the Reddit 60,000. You will notice something quite interesting. Even judging human conversation don't always agree that, you know, a human conversation is human-like all the time. So maybe because of spelling mistakes, maybe because of course, our subjective views about things. So not all the time will all humans agree that human conversations themselves are human. Yeah, so here are some results from a demo that we did. We tested with some foul words in Swedish and English. You will notice the first one, where this phrase by a human is usually considered offensive in Swedish. But interestingly, because this is trained on the GDC, it doesn't respond in kind with a foul word. It just says something like, it is so, it is a book, and that is the way, with nothing wrong with it. Something not so coherent. And that's one of the challenges of open domain conversational systems, the ability to have coherence. And of course, the amount of data we fine tune on has an effect on this. You will notice with English, where we use another file language, interestingly, the model too doesn't respond in kind. It just says, okay, goodbye, which I find very interesting. And then the user says, I was just joking. But then he says, I am sorry, but you sound somewhat confused. Would you like to help in booking a taxi or lodging at the Kirkwood House? So it practically just changes the subject and moves on to another discussion. So you can test the models yourself. The English link is there, the Swedish link. There's more coherence with the English conversations, maybe not too surprising compared to the Swedish model that we trained. We could also go there live and then see an example live here. This is the English model trained on the multi-words data set. And you would see example here of the training and then how you could use it also if you wanted to extend the work. And then, of course, this is what a test I carried out this morning, where I said, I would like to have breakfast, and then replied with that. And then as a user, I said, can you deliver it to NLDL? And it says, oh, it can, but I need to know what day and time you need, in addition to how many will be in your party. So it's quite interesting to see that the model has the ability to hold conversation, especially in single-turn conversations. So this is a histogram of the human evaluation that was conducted for the various models and then compared with the human dialogue. So concluding remarks, we found out that this work supports the hypothesis that deep monolingual models learn abstractions which generalize across languages, especially for English monolingual models. There's still need for more diversity and coherence in generated text. You will notice that there wasn't so much coherence with the Swedish model sometimes. And then perplexity is not enough as an automatic metric. I think more work will need to be done there. We see clearly that transfer learning abilities of language models are impressive and they can be used. So for us, future direction is to actually explore a more optimal decoding scheme. This is from Hosman et al., where they compare beam search with the human distribution itself. So we see that there's still a large gap between the two. And then we're looking at the possibility of combining text generation with idiom classification prompts. And then automatic conversational data generation for low resource languages. And then also translate this into the speech domain. So essentially, that is our presentation. Thank you for your time.